Hello and welcome to another fun-filled day in math with Mr. Sense. Today we're talking about triangle similarity and proportionality. And basically what that means is we're just going to look at some triangles, right? And we're going to ask the question if these triangles are, oops, sorry, I need to make my layer, there we go. We're going to ask the questions if my triangles are similar. Well, actually, let's talk first of all about what similarity is, just in case you're struggling with that concept. So let's start at the beginning. So if you're talking about similarity, I want you to understand that similarity does not mean congruence, right? Like if we're talking about triangles, for instance, let's say I just have this triangle right here, right? Let's say this one. If I have that triangle, right? And let's say I were just to copy it. I'm just going to copy it, right? Oh, let me just circle this, and I'm just going to copy. Edit, copy, edit, paste, right? So I've now made another layer, right? I'm going to transform that layer and move it just over here. So what I have now is an exact copy of that. This would actually be a congruent triangle, right? But with a similar triangle, it's not congruent, it's actually dilated. So what they've done is they take and they shrink it, or they grow it. All right, and you'll notice what happens when you do that, right, is your triangle has some very cool similarities, right, to the original triangle. So for instance, between these two triangles here, this let's say my points were labeled A, right, B, and C, if these were the vertices. Then this was, let's say, F, G, and H, right? I could write this. I could say triangle A, B, C is similar to triangle F, G, H. Now I want to stress to you the order of these points matter because when we just copied and pasted it over, so we know that this angle is congruent to that angle. We know that this angle is congruent to this angle, and that doesn't change when we copy it over. Okay, so now that you know that, the really super important thing about that is because all of those angles are the same, we know that these are similar. And what that similarity means, it means that basically there's a couple of different concepts wrapped up in there. Okay, similar means that the angles are congruent, right? This is so ugly. Let me try that again. Sorry. So the angles are congruent, and it also means, though, that not only are the angles congruent, but the sides are proportional. And when we say the sides are proportional, this is actually the thing that we're going to use the most, okay? That the sides are proportional. We're also going to use the angles are congruent, but we're definitely going to use these sides being proportional because we can do some ratios. I'm sorry about the chicken scratch there, but you get the idea that what that means, it doesn't mean that this side is congruent to this side because they would have to be both the same size and the same shape, and they're not the same size. So therefore, they're not congruent. But let's say this one was 6, right? And let's say this just happened to be half of that, 3. Then what that would also mean was that this side here, which AB, which relates to FG, right? Well, once again, we follow the pattern that we've established here, right? So AB and FG would also be proportional. So if this was 8, this one would be 4, okay? And so on and so forth. Okay, so basically what I could do is I could set up a proportion. I could say, okay, well, 8, this side 8 is to this side 4 as 6 is to 3. Now I want you to notice a couple things here. Notice that my big triangle pieces, right, numbers, were on top. They stayed on top. The small triangle pieces were on the bottom. All right, so super important that you get those right. You can't say that 8 over 4 is equal to 3 over 6. That would be wrong because this is a big triangle piece. This is the big triangle piece would be on this side, on the opposite side, so that makes the ratio messed up. So you don't want to do that. Now what you could say though is that 4 over 8 is equal to 3 over 6, okay? And if that confuses you anymore, you might want to reread the notes for Unit 6.1 where it talks about those proportions a little bit, all right? Without belaboring that point, I'm going to go ahead and move on to some actual problems now. We actually did a bunch of these the other just today, in fact, on our Unlock That Meme activity. So let's go ahead and tackle these. I'm going to start with two of the hardest ones that people found to be the case on the activity. So this one was the first one that a lot of people found hard. It was 13. And so I'm going to recognize that these are two similar triangles. If I wanted to, I could actually split up these triangles, right? I would have this triangle here. Sorry, that's just ugly, but like this triangle here, it looks something like this. And I would also have the bigger version of that triangle, right? Like that, right? And so of those two triangles, right, you have you could list out the sides. This is 57x plus 13. You don't have to do this step. This just helps some people see it, right? Now the question is, how would I get this side here? And this is probably what stumped a lot of people today, I'm betting. So anyway, this side is 357, and this side is 651, right? So I can make my ratio then 651, sorry. So what I can do with this problem is I can set up a proportion of 357 over 651, right? This amount over that large amount, right, is equal to is equal to 57x, right, plus 13, right, over 574, right? And this is where a lot of people got stuck. Plus 57x plus 13. Now I want you to take just a second to see, what did I just do there? Right? All I did was I took this amount here, these two that should be that are separate, and I put them together to make that final amount that I needed to correspond to this 651. All right, so that I didn't do any weird things there. I basically just added them together like you're supposed to, right? To get that total amount. So now you're looking at this and you're like, wow, that's ugly, but right, we can solve this. In fact, one thing I'm going to do is go ahead and simplify this. You can divide both of these by 21. I didn't know that off the top of my head. I knew it could be simplified, so I decided to figure it out in the calculator. And so it ends up being 17 over 31, right, is equal to, once again, is equal to this 57x plus 13, right? And that's over, right? Let's see, 574 plus 57x plus 13. I can add the 574 plus 13 here, right? So I have 574. Oh, let's turn that on. 574. I'm working with the junkiest calculator that I have in the world, but it works, right? So that's the thing. Like, you don't need anything super fancy for this, right? 587. So I now have, where'd my pen go? There we go, sorry. So I now have, what's this? Why is this not, what's this doing? Hello? I want to draw on you. Why are you not working? There we go. That was weird. So it ends up being, what is that? 580, what was that? 587, right? 587x, right? Plus 13. I'm sorry, I don't know why it keeps connecting my numbers together. I'm trying to figure that out and sort that out, but I'm not sure why it's doing that, okay? So 580, no, I'm sorry, I just messed that up. That was 57x, right? So the 57x stays the same, 57x plus, and this 574 plus 13 becomes 587 plus 587. All right, so now that I have that, right, I'm going to cross multiply here. So I know this one's ugly, but I want you to see that you can do this, right? You're just cross multiplying, right? So I now get a 31, right, times 57x plus 13, right? Right, I cross multiply those two, is equal to 17 times 57x plus 587. All right, so you have those two now. And what you're going to do is you're going to just have to distribute that in, right? And this is one of the uglier problems that you can get of this variety. I just want you to know, okay? So don't be alarmed if this is the one that you really struggled with. We're going to get to a couple that are a little bit easier here in a second. But I just want you to understand that you know, you can still do this one, 31 times 57, right? It's really just a matter of the problems just being kind of big numbers to work with, which makes it a little bit annoying, right? But aside from that, it's not a bad problem, right? 1767x, right? Plus 13 times 31, right? 13 times 31 is equal to 403, right? So this is 403. Sorry, that's a 4. For some reason, connecting those is really driving me nuts. 17 times 57 is 969, right? So it's equal to 969x, right? Plus 587 times 17. 9979. 9979, right? And now it's just a matter of what you normally do, right? You subtract 969x from both sides, right? 969x from both sides, right? And you do that and you get what? What do you get? You get 1767 minus 969. 1767 minus, right, minus 969 is equal to what? 798, right? So I have 798 x plus 403 is equal to 9979. And I'm going to go ahead and subtract 403 from both sides, right? Subtract 403. All right. And you get 798x is equal to this ugly number. What is that ugly number? It is 9979 minus 403. Now, if I didn't make an arithmetic error in here, I should get 9576, right? 9576. And then I can take that 9576 and I can divide it by what? Divide by 798, right? Divide by 798. And if we get a good answer, hopefully, yes, we get 12. So x is equal to 12. Okay? So that would be my answer for that one. My answer is 12 because they didn't ask me to find a particular length or anything like that, right? They're just wanting us to solve for x. So my answer is x equals 12, all right? So I want you to see that was probably one of the uglier problems just because of the large numbers. Really, honestly, aside from the large numbers, it was fairly straightforward. The biggest kink probably was this here, not understanding that you can get the total length by adding those two together, okay? All right, let's go ahead and do another one. So this one was another one that people struggled with. And once again, you'll notice there's big numbers, right? So these big numbers throw people a little bit when they see them. They kind of freak out when they see the big numbers, right? So let's go ahead and figure this out. Let's set up our proportions, right? So one of my proportions, oh, I could even use these sides for proportions. That's fun. So let me go ahead and do 320 over 528, right, is equal to, and they want us to solve for x, so I should probably do something with this x one here, right? So I'm going to go is equal to 700, right, over, and I want to get this whole amount now. So, right, I'm going to do the, on the bottom, 700 plus 21x minus 49. And once again, you'll see the same trick here, right? Minus 49. Now, later on tomorrow, like I said, we're going to learn a trick that's going to make this even easier for us, right? But for now, this is how you could have done it, right? And so what you want to do is it's a matter of cross multiplying, but before we do that, we always want to see if we can reduce that fraction, right? Because it'll save us so much time, right? So 320 over, what's that, 528, right? Calculate, what's that going to be, 20 over 33, right? And once again, your calculator does the simplification of fractions for you, right? So you can use that. Even the little four-function calculators in our classroom can do that, okay? So 20 over 33 is equal to, and you could have, kept doing it by dividing by 2 and stuff like that, but right, just to be a little faster, 20 over 33 is equal to 700 over, I could go ahead and add these together. I'll get the 21x, right? 700 minus 49. What is 700 minus 49? Minus 49 is equal to 651, okay? So plus 651. All right, so now that I have that, I'm going to do my cross multiplication, also known as your means and extremes property, right? So I'm going to do 20 times 21x plus 651, right? I hate it when it does that, is equal to, right, 33 times 700. Okay, this is 700, sorry, 700. So what I should get after doing that, if I zoom in, right, I can now distribute in that 20, right? So I have 20 times 21. What is 20 times 20 times 21 is equal to 420. So I have 420x, right? Once again, don't let the large numbers freak you out, right? 20 times 651. In fact, in life, when you get into some engineering jobs or something like that, you're going to be working with millions of gallons of stuff at times. And so you need to get used to being able to handle big numbers and scientific notation and things like that that's going to be coming your way. So don't freak out just because you see big numbers. All right, 33 times 700 was 33 times 700. Oh, 33 times 700 is equal to 23,100. Okay. All right, so now that you have all that, right, you're going to go ahead and take and subtract 13,020, right, from both sides, right? And these cancel out. 23,100 minus 13,020 is equal to 10,080. So this ends up being 10,080 is equal to 420x, right? And then I would divide both sides by 420. 420 divide by 420, and these cancel out, right? And so I get 10,080 divided by 420, which gives me what? 24. So x equals 24. All right, so that's x equals 24. And that's my answer, because that's all they want us to find. They didn't want us to find the length or anything like that. They were kind to us. So x is equal to 24. All right, hopefully that made sense so far. All right, let's move on to the next problem. All right, so this one here is another problem. This one should be easier. Oh, shoot. Didn't want to do that. What did I do? What did I do? There we go. This one, it should be a little bit easier than the other problems that we were just doing, right? So once again, we have our angle, right? They tell us that STU, right? So ST being the first two, so ST would be this one here, right? And SL, so this one here. So they were nice. They lined up our things so that they look similar too, right? But the nice thing about this is this one's pretty straightforward. You have your 624 over your 1,222, right? Is equal to your 912, right? Over your 43x minus 278. Okay. So now that I have that that ratio, once again, it's the little to the big, little to the big, right? So this part, basically, we're saying 624 is to 1,222 as 912 is to this, right? So anyway, knowing that, we can now go ahead and cross multiply and solve for x. But before we do that, like I said before, you always want to just double check to make sure that you can't simplify your fractions a little bit, because let's face it, it's just so much easier if you can, right? You're working with smaller numbers. 624 over 1222 is 24 over 47, right? You can divide both of them by 26, right? So, okay, hello. I want to work with you. Why won't you play nice right now? There. Okay, for some reason my thing just decided to be weird. Okay. There we go. I don't know what that was about. All right. So that ends up being 24 over 47, right? That 24 over 47 is equal to that 912 over, and I didn't need to do that step, by the way. That is just a step to make the numbers a little bit more manageable, right? We're having to just write less digits. Less digits will mean the difference between perhaps you making an arithmetic error, right? So yeah, it definitely can help to simplify first, okay? All right, I'm going to go ahead and cross multiply now. So I end up with 24 times, 43x minus 278, right, is equal to 47 times 912. Okay. So now I'm just going to go ahead and simplify. I'm going to distribute that in as well. 24 times 43 is, let's see, 1032, right? So I have 1032, right? 24 times 278, really negative 278, right? Oh, sorry, that's 1032x, okay, very important. And then that's going to be minus something, 278 times 24, whatever that is. 278 times 24, right? Which is equal to 6672. So is equal to 6 minus 6672 is equal to 47 times 912, which gives me the lovely 42. Whoa, that's a large number. 42,864. I wonder if I typed that in right. 42,864. If I don't get the right answer, then I probably typed that part in wrong, but I'm going to go with it. So, all right, at this point, I just am going to add 6672 to both sides, right? Add 6672, right? So, yes, these problems have big numbers, right? But don't let that alarm you, right? Get used to big numbers. They are not going away. Now on the test, in order to make it probably more manageable for you, I'll probably try and make those smaller numbers, right? Because I'm not a complete ogre, you know what I mean? Like that'd just be too much. Which is 49. So it ends up is equal to, is equal to 49536. Okay, and then I'm going to divide by 1032. Divide by 1032. And I get x is equal to, which ends up being 48. So x is equal to 48. Now the question is, do they want us to find the side length, or are they happy with the x? And the answer is they're happy with the x. So x is equal to 48 is the answer, okay? All right, I hope that these are making sense for you. I'm going to go ahead and do one last problem. I had a few more that I could have done, but I feel like that that's about all I have the energy for at the moment, to be honest. And then if you are still struggling, I can always try and make another video later on that maybe does some like simpler problems or even more hard problems if you just need. I'm going to go ahead and do this one here because this is one that you might have struggled with. Okay, so let me go ahead and rock this like it's 1999, and then we'll call it good for the evening. Okay, so this problem here, you have triangle SRQ. Once again, it's important that you recognize the order. The SR, so this length here, SR, is 520. Notice that that corresponds to this SB length. Oh, I'm sorry. This is SB here. SB. I'm sorry. The B got cut off just a little bit when I cut it. So this SR here corresponds to this SB. In other words, what they've done is they've rotated the triangle like this. To get it to this position, okay? So you could, in theory, rotate it back, and then you'd have, like we were doing, the triangles that are on top of each other, okay? But anyway, let's go ahead now and just work with the 520. So 520, then, 520 is to 800 what, okay, once again, since I've used this 520 here, I wanted my next one up on top to be this 3x plus 194. So 3x plus 194, whoops, is to 800. No, to 520. All right, cool, huh? And that just happened to be 520 because both of these were 520, okay? So this one is to this one what this one is to, no, what this one is to this one, okay? So that's how we did that, all right? But anyway, once you have that, now, like I said, you always want to just make sure that you can't simplify your fractions, right? 520 over 800. I know that one simplifies. The question is, what does it simplify to? And I will find out post haste. Calculate it. 1320. Woohoo! So I have 1320, 13 over 20, right? Which is going to be way nicer to work with, right? Let's face it. So I have 13 over 20 is equal to, oh, please stop doing that, is equal to 3x plus 194. Oh, it's going to drive me nuts. Over 520. All right, so now that I have that, right, it's just a matter of doing that cross multiplication thing, right? So the means and extremes property, I'm going to take and cross multiply this, right? Like you did all going through middle school, right? So 13 times 520 is equal to 20 times 3x plus 194. Okay? So now that I have that, I'm going to go ahead and actually multiply them. So 13 plus 520, right, is, oh, sorry, not 13 plus, sorry. 13 times 520, once again, this is going to be a large number, right, is 6,760, largish, is equal to, this 20 gets distributed in, which is 60x plus 20 times 194, 20 times 194, which is equal to 3,880. Okay, so 3,880. So now I'm going to take and now that I have this equal, right, I'm just going to subtract 3,880 from both sides, right? And I should get 60x is equal to 2,880 I'm going to divide that by 60, which is equal to 48. So x, x is equal to 48, and 48 is the winner chicken dinner for that problem. All right, so I just want to review real quick a couple things that we did, and then I'm going to sign off for tonight. All right, hopefully these were helpful examples. I do know that with the large numbers it does make it tough, but let's look at, ignore the large numbers for a second, and let's look at the process that we did. Right, basically what we did was we created ratios. Right, we used the 357 is to 651, what 57x plus 13 is to the total, and we came up with the total by adding the 57x plus 13 to the 574, right? So that's how we got this number here. So we used that trick there, right? We also used that trick over here. We did the same exact thing when we added these two, right? These two numbers here to get a total that was going to work for us, right? So we did that here with this this here with the 700 plus the 21x minus 49, right? So we added them once again to get that total amount, right? So that trick is going to be a useful trick for you at times, okay? So I definitely suggest looking at that one more time, especially if you didn't understand that real well. Look at what we did. And then finally, this one, once again, was a pretty straightforward one where it's just the proportions, right? You're setting them over. Once again, don't let big numbers scare you. Get used to big numbers because you will see them, right? Especially when you start working in chemistry and stuff with Avogadro's number, which is huge, right? Moles of a substance, which are also huge, right? You're going to be working with large numbers. Get used to them, okay? So these also, once again, this was a pretty straightforward problem. One of the things you had to realize was that these were similar triangles, right? In fact, these angles are the same, right? They tell you they're similar, and you had to recognize the SR here related to SB. So you do have to get that right in setting up these proportions, okay? But from there, once you got the proportions set up, it was pretty straightforward. All right, so anyway, I hope this helped a little bit. If you need more help on this concept, go ahead and reach out to me, and I can see about making another video, like part 2 of this, right? The legend continues. But basically, hopefully this is starting to click a little bit for you based on some of those examples and some of the things we did today. So anyway, wish you the best. Thank you for all your hard work, and good luck on your test on Friday.